Welcome to Brain Vision.
In this problem, we're asked to revisit the previous problem, and let me pull this up, and see how much error is caused in the thermal efficiency if the power required by the pump were completely neglected. Okay, so we have in previous problem, I flip back to that. Again, we have an isentropic pump, and so the power that the pump um, puts in is this amount, right? And so we can see that the net power is this amount, specific power anyway. And so you can see that this is like 1% of the power, the net power that's out. So if we took this, if we neglected this, we would just have this would be roughly 440 um, uh, BTU per pound mass. So we shouldn't get much of a difference, and we'll see that that is indeed the case. So um, we'll kind of proceed as before. So everything up to this point is exactly the same. And again, I calculated this, but we're not going to use it. I think, yeah, this is also the same, right? And so what we're going to do here is just, we can figure out the net work that's going out from just the change in enthalpy from here to here, right? And that will give us a mass flow rate. Now, we can see that we have a little bit different mass flow rate, um, and it is slightly less because we basically, to get the same power, we need and we're neglecting some of the work that we're actually doing, so we'll need less of a mass flow rate. Now here we calculated the net work, or the specific work in a little different way, right? So here, the specific work, we calculated it from here. Over here, we did it by taking the difference in these energies, or these heat transfers. So either way, you can see how that, if you were to plug Q in here, you would get that was, let's see, H3 minus H2, and then minus Q out, which is H4 minus plus H1. So you can see here what we're doing is we're basically saying that H1 and H2 cancel out. So roughly that these have the same enthalpy. And so that's why we get H3 minus H4 here. And then we can figure out the heat transfer in. We can see that it's a little bit different from over there, because again, we have a different mass flow rate. And so I think the enthalpies between here and here are the same as in the previous problem. Let me see here. Is that what we did? Is that what I did? Let's see here. Yeah, I must have done that. I was thinking that maybe I had used the enthalpy here as instead of 2, but I think no. I think I'm. Well, let me see what I did. That may supposed to be a 2. Um, okay, come on, load up. My notes are let's see here. Let me try to find them. Hold on, let me actually just try to get this sorted out here. I suspect that I actually used H1 here, because if we're gonna neglect this power, essentially, basically, we're saying that it goes up in pressure, yeah, but we're not. I'm not sure what I did. Let me actually check. Oh goodness. Trying to find my notes here for this problem. think I may have just didn't really do it very closely because of it was just kind of a repeat of the previous one. So where did I put the notes? Hmm. 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 Let's see here. Anyway, regardless, you can figure it out, right? Whether I used H1 or H2. I probably should have used H2, but if we're gonna say that, the pump work is 0, then H2 should be equal to H1. And so, it's kind of a very minor difference what we'd get out as far as the differences that we might get out or might see here. I can't find it in my notes. Anyway, you can check whether whether I used this is either H1 or H2. I can't remember what I used to calculate this. Theoretically, if we're going to ignore this, then we're going to have to say the enthalpy is the same. But then we know that it's not the same state. So, I'm not sure exactly, are we just ignoring the work um, in, the energy, the power input in the network, or are we neglecting it in everything? Um, Again, let's see here what we have. Um, anyway, it's going to make a very minor difference because, in fact, neglecting this, we can see that our efficiency is now 34.82%. Before it was 34.5%. And so we get a change in our thermal efficiency of about 1%. So again, we get about a 1% change, which isn't surprising because um, we had a 1%, this was about 1% of this. So it's not surprising that we just get a 1% change here, and that, neglecting the work, the work going from here to here is very small compared to what's happening from here to here. So a lot of times this is just neglected, the work done by the pump.